Hello everyone. In today's video, we will be creating a 64-bit virtual machine inside of Rust. So the aim for today, the aim for this entire product slash project is that we are going to make an entire 64-bit virtual machine from scratch in the Rust programming language. We are going to we are going to make have it many things like a complete virtual machine. It has its own memory, etc. uh, at the same time we'll try to make it without any libraries, external libraries in Rust. Secondary, we're going to also support for assembly, such that you can write some assembly, such as like something like push something, pop something, something like that. We can also have registers. uh, so it's going to function like a real 64-bit machine, but instead we're just going to make it virtual a 64-bit machine. So yeah, so this is what we're going to make. So I think we can get started actually. So we're making Rust VM. So the name of this project is Rust VM. So yeah. So the plan actually is that we need a few things. For the first thing is that we need memory. Obviously, we need memory. So this memory is the first thing that we're gonna handle, right? Then we're gonna think about stack. We're gonna think about the heap. Then what else do we need? We need assembly, of course. So this will be our last thing, but the first thing we're gonna do is have memory. All right. Yeah. So I think we can get started. So you can. So basically, what I've done here is that I just have generated one. So a new Cargo project. Okay. So what I'm thinking right now is how do we actually make? Okay, we need a struct, right? Okay, I think let's divide it into like proper this thing, or let's just get started with programming first. So you have a pub struct. I think it's good to maintain a proper file. Okay, so you can call it um how what should we name it? Amazing. So first of all, what I'm gonna do is actually mod all of this. Let's mod VM. So this should not give us an error right now. Amazing. So let's get started with abstract virtual machine. That's going to be the name for or we can call it Rust VM. So obviously the first thing a few things we need. What do we need? We need memory, right? We need memory. Um, it's not a string, but for now I'm just going to keep this a string. What else do we need? Let's just focus on memory now. So for memory, so this is my plan. Let's first of all make let me get a readme. First thing we're gonna make is a complete 8-bit virtual machine. After that, we're going to focus on making a 64-bit. So let's get started with doing this first. So again, how do you represent memory is a good question. So what I believe is that we can make a few vectors like this, right? 8 of them like this. You get what I mean? And also we can have, you know, binary over here. Some where we can have some binary, something like this. Obviously, it has to be 8 bits for. Let me just put something like 1, 2 for now. So there'll be 8 of them like this. Yeah, 8 of them like this. So this is how the memory works, right? So it'll be 1, 2, 3, 4, 5, 6, 7, 8. So this is how the memory looks like for an 8 bit, which we can represent the memory like in this format. So the first problem we're going to encounter is memory is going to be abstract again. Wait, no. Memory. So how do we represent this? This is a vec. It's a vec having multiple vectors, right? Is this even, can we do this? Because uh, something like this. Is it possible? Okay. So that means this is how it's going to be. Obviously, we can't use string because that's not good. But let's take a lifetime, right? Oh, nice. So the first thing that I'm going to do is actually um, allow this thing. What is it called? Non-snake case. Yes. Now, obviously, we need some traits. Let's go for debug, clone. What else do we need? Partial equal to. For this is enough. I think this is enough. So that's what memory is going to be. This is our memory, right? And then we're gonna have a lot of commands to like push into the memory, pop off the memory. And one more thing that we need is actually an ID for each and every one of them. So the ID can be represented by something like row column. So the first one of them over here is going to be 0 0. Next one is going to be, so wait, I think let's make it row column now. Let's make it column row. First is the column. So it's going to be 0 1. Next is going to be 0 2, something like this. This is our going to be ID. So obviously the ID should be a string, right? Like this. Also should be string. So that is what we call as an ID. Now, each and every one of them should have two things. One is an ID. The second thing is like what I mean technically is that each and one of those, let's call them cells of the memory, right? This is the first cell of the memory. So each and every cell must have an ID and a value. Default value will be 0, obviously. So now we need to, should we have, so we could have it as an hash map. It'd be great if we have it as a hash map. So if it's a hash map, how do you want to say it? It's going to be vector of, no, I don't think hash map is good. Let's get started with this first of all. Let's see what we can do with this. So I'm just initializing it, right? Okay. Uh, just like this. Mm, how do you? Oh, okay. We didn't add a return type. It's gonna be Rust VM. Yeah. Okay. So one more. Oh no. One more thing is we're gonna allow dead code for now. For development, then we gotta, yeah. Let me go into main. Right. So let's say it's equal to Rust VM. Continue. Right. I like for small thing, then yeah. That looks good. So um I'm not really sure what to do, so let's just print it for now and check whether everything is working properly. Amazing, we get everything working. So now let's actually get started. Right. Um so one more thing is that when we add into the memory, we need to check whether everything is free or not. So we need kind of a flag that says whether it's free, yes or no. So again, we need the IDs, The IDs are really very important. Everything must have an ID. uh, okay, so I think we can get started with the first of all the push function, right? The push. So what are you gonna get? You're gonna get a value, right? A value. What is that value gonna be of? A string. Technically, yeah, because we're gonna take in binary values, right? Converting, we need to convert into from ASCII to binary or whatever, like whatever data type. We need to make sure that we can convert them into some kind of hexadecimal number. With that, we're gonna convert that into a binary. So that's how it's gonna be, right? So push. And yeah, one more thing that I forgot is that we have to initialize this everything to zero. That's a very important thing. So I'm gonna do vec colon new for now. What I'm gonna do is make a separate function, um, init memory. Right, so this is going to return a vector of a string, right? Oh, okay, so taken. Ooh, I, I'm not really sure we should replace the lifetime. Okay, we don't need a lifetime. We can just do one string example. Oh, okay, that makes sense. Now, what if I do this? Where am I supposed to use? Okay, here, I believe here. Okay, no, it's not there. Maybe here after this. Yeah, come with the identifier to. I said no snake code. No snake case. Not sure why it's not doing that. It's supposed to be like this. Okay, we'll do that later. Right. Uh, yeah. So what I'm gonna do here is actually do init memory that takes in nothing, but we need to give a lifetime. We don't. Okay, then I don't really think this is necessary for a lifetime here. I think this is enough. So you're more likely want to return an owned value. Okay. Yes. Exactly. We need a lifetime. Amazing. The first thing that I want to know is why is it not allowing me to use non-snake case? Allow non-snake case. Is it because there's only one like this? No. I need to figure out why it's not allowing me to do that. Because if you put it at the start of the file, it should actually do it for every single thing. We'll see that later on, right? We'll see that later on. Okay, we are recording. So we're gonna return a vector having one more vector. Obviously, this is when we're not gonna hardcode this. So for what do we say? Right? Mm, Okay, so this is what I'm gonna do. I'm gonna make a mutable vector called memory, which is going to be a new one, right? With new, and this should be of type. What are we gonna return here? The same thing. J. Yes. Right. So that's memory. What we're gonna do here is through one of them, we actually gonna insert memory dot push. We're gonna push in a new vector having values 0 0 no. So 1 2 3 4 5 6 7 8, right? 8 times obviously, so we're gonna return memory here, right? Twice, three, 4 5 6 7 8. Okay, so I think that's good. The first thing I'm gonna do is actually push into this. So here what I actually want, so what I want to see is, let me run this so we can see. Yes, this is what we want. This is amazing. This is the memory that we need. So okay, this looks good. Yeah, but the thing is that when we push into this, right, the first place we're gonna push it into is 0 0. Now 0, the next time we're gonna push it is gonna be in, so wait, let's just write this down. So the first time we're gonna push it in is going to be in 0 0. The next time we're gonna push it in, wait, I think I can, okay, no, 0 0. Next time 0 1 and 0 2. Now what I'm gonna do is actually free 0 1, right? So it's gonna be nothing. And next time I'm gonna push it, instead of using 0 3, we are supposed to check whether 0 0 has something. Yes, skip. 0 1 has something. No, so we're supposed to put something over here, right? So this is how we actually push it. So the first thing we're gonna do is we're going to get first of all mutable self, right? So again, self dot memory. We need to check one of them. So again, a for loop. So for 0 through 8, what we actually gonna do? One more thing that I want to do here is that I'm gonna make a constant bits, just an integer 8. So I'm gonna go to bits because we're gonna change 8 to 64. So I don't want to do that again and again. Obviously, we gotta change this. Oh yeah, we need to change this. We need to make this 64 times, which is, so we'll have to put another this thing. So we'll do that later. Mm, so set our memory, right? Of, okay, we need I here of I. We need to check the separate memory of I. One more thing, we need the second thing. So we need to make this to become of n square. Is there any other? If you use a hash map, it won't be of n square. It's a hash map. How would you want to give in hash map? So if a hash map is going to be an entire vector, instead of that, it's going to have an hash. It's going to have one hash map. Um, the hash map will consist of what? An ID, right? And it's going to data something like this. So we'll have this eight times. And again, okay. So I think this is pretty good. We can make this in a hash map, which makes it not of n square. So instead of making this a vector, we're going to make this into a hash map. I hope you import it. Yes, good. You're not supposed to import it here. Yeah. So we're gonna use that. What happened? Oh, Go BDIW. What's it? Hash map. So we have a hash map of what? Hash map of a string. First one, a string. Um, yeah, that's the ID. So this is totally not necessary, but I'm going to define a type called ID, mem ID, which is a use size, right? I don't think that's it's supposed to be small case MID, yeah. Converse. Oh, okay. If you say so, let's do this into this case. Um, mem value. We can do the same. No, it's not use size. It's string. Okay, now mind. I don't think this is gonna be useful for one case, so we can just do this. We'll see about that later. We'll see about that later. Now, this entire init memory thing is changed. First of all, it's gonna be like this. Second, it's gonna be like this, right? Um, so this is not how it works. So I can undo. Yeah, here we're supposed to memory dot push in push what? Push in what? Um, a hash map. Hash map colon colon new. We're defining a lot of hash maps. Like that's actually not good. We're gonna give it an ID. Now, ID is gonna be call row. So the column is gonna be okay. So we need to get a track of column and row. So this is gonna take in call. Okay, sorry. This is gonna be what do you say? Yeah, column and row, and this will give us a string which we want to do as string like that, right? The second thing we're gonna give in the data, which is 1, 2, 3, 4, 5, 6, 7, 8, like that. Okay, all right. So it's a lot of columns. Let me not push. This takes in one argument, but two arguments were supplied. All right, that's because we didn't put the closing bracket here. We need to indent this. Okay. Okay. Also is good. Now, expected zero arguments. Oh, why did I do hash map colon colon new? Wait, no, you need. Now this is the big problem. We need to insert into the hash map. Oh god. Wait, no. Wait a minute. Vector of hash map. Wait, this is wrong. This should be vector of hash map. Or wait, no. Wait. So I think the first thing. Okay, wait. We gotta represent this. It's gonna. It's gonna be a vector, right? I'm gonna take in a hash map. I'm gonna just hm. It's gonna take in an ID. It's gonna get data, right? Eight of those here, right? Eight of those here. Eight of those here, like this, right? Now, how are you gonna fetch this? You have to actually give an ID, and it will give you the data, right? So the first thing that I realized that this will is like this. So it's a vector of hash map. Now the second thing I realized is that why do you need a hash map? Because you're going to store only one value. But now I realize that that means we don't need an array here. And it's going to be a single hash map for each and every row. So there's going to be row and data like this, right? We could we could take it a step further by having this is our plan here right now, right? This is a plan here. Do like this 8 times. We could take this a step further to make this as like this: ID and data. Now the two things that we're gonna think about. The first thing is that are we gonna make it from scratch? Like from scratch means this not gonna be hash map. Like we're gonna go like the C way. So there's not gonna be no hash map. We just wanna have the way I just told before, right? Then array have array. Thing is that that's really slow. Number one, but the advantage of that is that it's just a vector stored in the memory. Here, as of right now, I'm not sure how. I think what I believe is that when you make a hash map, it's like an array, and it's like, what do you say? It's kind of a delimiter. So you have so many values. So memory is like, I mean, we can't really do anything at this point. So I think the first way is doing like this and like this. Second way is doing like this. I think doing this way is better, right? This way it's better to retrieve. So we're gonna do it like this, right? So the first thing is that um what do we say? Hash map row. So we're gonna push in one hash map with a row, which is gonna be, we don't need call, we just need row. It's gonna be row, right? Row, and we need to give a data. Now data is actually a vector. So this is going to be a vector of a string, right? You know what I mean? This is gonna be very complex. Oh no, I don't think. Yank and paste. Nice. Still recording. Okay, 28 minutes. Okay. All right. So we got row. Amazing. Row. Now what we need is a new vector, right? Vector having 8 different values over here of 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Something like this. We gotta make 8 over here. Now the first thing is okay. The first thing is that it's gonna be hash map colon new. All right. You gotta insert this one more time. So I think this is the first time we're gonna do it. The second time what we're gonna do is we're gonna do the same thing, right? For in this thing, 0 to, or wait a minute. This symbolizes columns, right? So yeah, so for column in this thing, I'm gonna say memory of column dot. So that's gonna be memory of column is gonna be a hash map, right? Right? Not unsafe or unwrap. Wait, so memory of column. Oh yeah, good point, good point, good point. No, wait a minute. It's gonna be a vector of hash map. It has to be a vector of vectors of hash map. No. No, it's gonna be like this. So a vector of hash map. Yeah, everything's right. So vector of column, memory of column. What's wrong with this? What's wrong with memory of column? Memory is this entire thing. Of column is gonna be this value. So can be indexed by I8. So if I do 0, you won't tell anything, right? Okay, so uh, you're taking it as I8. I want you to take it as U size. So not pass. Now, how do you? convert an I8 into. How do you do that? What do you say? Convert. Yeah, convert I8 into U size. First of all, how to access element in an array with type of I8 interest. So no, not this. Convert one type to another. Rust. Casting, yes. Casting. Okay, okay. How did I just forget that? Amazing, let's go. So, um, yeah, dot. We have to insert. Let's go. This is the best. I love Rust. So, insert what? Row. Row. Obviously, row. And we need to do that. What's the value? The value is 1, 2, 3, 4, 5, 6, 7, 8. No, no, we need to make it a vector. Vector of this. Sorry, what am I even doing? Yes. Amazing. Amazing code. Right? What we need to do is we need to um 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 um, 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 why is this okay? Why can't I make the row as U size? Right? This can be U size. This can be U size. Amazing. So by this means, got a problem. We ain't doing that. We ain't doing that right now. Just wanna do this. So a new hash map here having zero. What is zero? Zero. Wait, we don't really need this, right? To be honest. Wait a minute. Wait a minute. Wait a minute. Wait. We're not supposed to do this. Oh, you. Oh, okay. I think. I think I made a big mistake. Yank, paste. I'm not sure how to explain it, but this is how you do it. This is the solution. This is how you do it. Cargo run. Is this what we need? Uh, uh, no. What we need is we need this into this. Why is that not happening? For this in this 0 to 8. 8. You're gonna push hash mark name. So it's gonna push it many times. But is that what we need? Is that what we're doing? We need row data. So it's a hash map. So this one should be over here. The entire concept is wrong. If you know how many hash maps, this should be 8 hash maps. Alright? The columns define like this, right? You insert Yes, but the column increases. No, I think we are doing a big mistake here. I just so so I think the way we defined it is wrong. It should be no. The definition is correct. The vector of forcing should be rho, right? The rho. So the way it should be represented is this. All this right. This one should be inside of this object, right? This one and two should be instead of this curly braces instead of this object instead of this. This is where it should be. So when we insert it, right, what is happening? What is the first thing? What is happening is that before we do this, right, I'm gonna go GC this. So I want to just see what's the plain output. It's a bunch of hash maps, which is uh, okay. So the first thing is that we have an object. We need to insert two things: an ID and a thing. Now, what I believe is that our definition is wrong. Right? I think representing in this way, it should be like this, right? Right. Let's go full JavaScript. Yeah. So ID data should be a vector. All right. This is it. This is exactly it. So what is going to be the type? This is going to be a type of a vector, right? It's going to be a type of a vector. Inside that, it's going to have one more vector of a hash map of an ID. Okay, this is how it's going to be, right? So let's go here. All this one, a vector of one more vector, right? A hash map having an ID which is this, and having a data of this. If I'm not wrong, this is how it's supposed to be. Now, the first question arises is that why do you need an hash map? Which is the best question. Why? Because you need a, what do you say? A struct. A struct is what you need. It's supposed to mean memory value, right? I'm not good at naming things, but it's gonna have an ID of a string. It's gonna have a value of a string. We need to get what do you say? Lifetime, right? Uh, do this over here. What's wrong with it? Okay, myself. This has to be a memory value. All right, amazing. This is exactly what we need. Amazing. This is exactly what we need. So we're gonna get okay. We're gonna push a vector of a memory value. All right, having an ID as a string. There's gonna be a column, right? That's gonna be a column as a string of a column and a row, and the column, right? Column row as string obviously. It's gonna have a value of 1, 2, 3, 4, 5, 6, 7, 8. 8 times, obviously. Temporary value drop and mm, what is your problem? How do you say that? You put it as asterisk over here. Alright. You can't really. So, you're telling me that if I put it over here, you're telling me it doesn't level up. But if you want me to get an ID here, you also want me allow me to do that. So that's irritating. And I don't want you to do that. I want you to be a good boy and allow me to do that. But I don't understand why don't you allow me to do that. So temporary value drop while borrowed. Can you actually tell me what do you mean by that? Yeah. Okay. Type annotation request. I'm so stupid. Let ID is equal to this. How long does it live? For okay, this is yeah, okay. We annotate the type. Amazing. This ID. Amazing. Type annotation books. Okay, okay, okay. What do you want? Should what do you want? I don't understand what do you want. Mm. Type annotation requires the borrower for this thing. All right. Format this thing. Temporary value is freed at the end of the stat. Means? Oh, okay, 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 okay. So you basically, how do you say that this thing lives for like this? Is this how you say this? Oh, okay, okay, like this, right? Cannot find unit. I don't know. Getting doesn't live long. So, so like this. Is this what you want? Okay, so we'll do that here. No. I understand that the temporary value is freed here. A is defined. Okay, so A so in this entire scope. So this okay. Alrighty. No errors. Here we'll be doing this. ID does not live long enough. Borrowed value does not. Then how can you compiler? Please tell me how to fix it. So ID is declared here. Time machine requested ID is board for this thing. Or the best thing that I can do is go to the outer scope. Alright. So we can make this mutable. right column. um I'm gonna do that, right? We're gonna do that like that. You can be just give it so okay. So instead of ID, yeah, yeah, exactly. Now what's your problem? First of all, we need to change ID. So um type annotation requires the borrow that um, so here's what I'm gonna do. I think this is not what it's supposed to do. I think this is better. I think I believe it's gonna have one more type. So I still don't understand. Okay, this should not be mutable. No, this has to be mutable. I this has to be mutable. Never mind. What did I just do? Temporary value. Okay, I'm not sure about that. Enough what? Creates a memory value. Okay, type validation requires that borrow lasts for. Alright. Alright, so this doesn't live long enough. My question is who asked you to free that? So the problem comes here, right? I know this is extremely bad, but I have no other choice. I'm not crying. I wanna go into this. Ding, ding, ding. Okay, so I think there's some big confusion here. Okay, what exactly happening is that we need a call and a row. We need call here. So my question is, the thing that I am extremely worried now is that okay wait, format rust, right? it gives you strength. To concatenate literals into this thing, which we need, use the concat. Oh, so I've been doing the wrong thing for such a long time. I didn't know that concat existed. I can do this. But you're telling me I can't do this. May I know what's the reason? So, e- I want you to do this. But I don't know. Let's say a compile number. It is format. How to format to yes. So the best thing I can do is forget about optimizations and convert this, not this. You, you roaster. That's I can do that. That's going to remove all of the things. Amazing. Uh, what are these values? Oh. Okay, so Now what we supposed to do, right? Make a new thing. Make a for loop for mm, so that is a big problem now. The problem is that you can't really a for loop can't return really anything. That is a problem. So you can't put a for loop inside a vector. So the first thing that we're going to do is convert this entire for loop to its own separate thing, right? So this is going to be a vector. So I'm going to make a new function for this. Um, Initialize init memory value. That's going to be a vector of memory value, and it's going to take in a lifetime of a. This the thing. Let me indent this. So it's going to return. Yeah. Actually, yeah. You have to make this let mutable what do you say memory value val vals equal to the colon new, right? The type must be of type this thing, right? And we must say vals dot push our memory value here like this, and we can return vals, right? We're going to take in one more lifetime here. So the lifetime almost gone. Now the column is a big problem, right? So we can get that from here. Columns use size. I believe it's use size, right? So we're gonna do init memory value, yeah, and we need to give in a lifetime, I suppose. No, okay. What? Yes, this is supposed to be like this. We can copy the allow snake case thing. So that's beautiful. Yeah. So I think now I'm going to We can check how it looks, right? This is pretty good. This is what we want. But my question is that why is okay, all right. So it's not zero, it's one, right? Cargo run, still the same thing. So my other question is that we're starting at zero. It's not starting at zero. It should start at zero. Uh, oh yeah, because it's this, right? So yes, obviously, and this should also be this thing, and we can increase. Oh, so you can see here that this thing is right. We can increase the bit by one, right? We should increase the bits by one plus one, or else we could just increment it here, so it should always be one. So then therefore it should be 65. So you can see that it is amazing. We have created the memory for an 8-bit virtual machine, right? And the value is zero. So this is how it looks. Um, the next thing what we do want to do is that we need the way to push into this, right? One more thing we need is that we need a thing that says a flag that says whether 00 is free or not. We need to see that, right? We need to check that whether a certain ID is free or not. So how would you do that? There are like a few methods. What I believe is that you can have a vector, right? A vector of saying memory flag or something that gives in an ID and takes in a value, just like a memory value, but instead of a value it says whether it is free or not, which is a boolean, true or false. So if it is free, we can actually push new binary values into that memory value. So the thing we need to think about how we should implement this struct. So again we need to see how we're going to do this. So we're going to have struct, right? We can say um we have an array, or we could also have a struct that has id, right? id is id having what do you say, free, that's a boolean. We need a vector of those, right? Or the better way is to do a simple hash map having an id and a boolean whether it's free or not. So I think we can do that instead. So apart from memory we need, I'm not really sure how do you call it, is it flagger, uh yeah, flagger is a good name. Hash map is going to be a hash map, right? A hash map of what, of a key and a value. So the key is going to be our id, which is a string, right? And the value is going to be a boolean, right? It's the flag for the virtual machine. By the way, I'll put the GitHub in the description, right? We can have a flagger. We can initialize a new hash map, right? Amazing. Now, one more thing we are supposed to do is actually initialize this flagger properly. I think we can do that here. So we're gonna say let flagger is equal to hash map colon colon new, right? we insert something like um, id, which is twisting something like this. The value is going to be, what do you say, 0100, and that is going to be false, right? This is going to be false. So I think we can return two things here from init memory. We can also have something called init flagger. So we'll just call this init in memory. Actually, let we're gonna call it init vm, right? This is, it's not init memory, it's init vm, right? And this, it actually returns a new tuple of this like that, right? It's gonna return tuple having memory. We have one more thing called flagger. Expression has you want to return one more thing here. Let's just say bool for now so that we can see this working. True. So you can see it's working. But this is actually a hash map like this, right? Where is, yeah, here. This is a hash map, and we need to initialize that too, right? So this memory, next is let flagger, which is an hash map of a string and a boolean, right? It's a new hash map. So for column in this, we need to flagger dot insert um our id. Again, we need something like this, right? We need 8 of those. Or we could just make a new for loop for column in 0 to bits, right? We're gonna say flagger dot insert, or we could do open square for in bits. So we can say flagger dot insert format call row with what? By the way, we gotta return the flagger here with false. Amazing. You can see that every one of those is false. And my question is, why is it in this order? I'm not really sure. Right, I'm not really sure why is it in this order. So yeah, we can I'm gonna try. Is it 21 again from the start? Okay, so this I'm not really sure why it's coming like that, but I think pretty good. Right, so all we did was just initializing. Now it's the time to actually push. So first thing, I think we can push it. Yours, never mind. So we're gonna take a add much self, obviously. You're taking a value which is gonna be a string. We're not gonna return anything, right? We're not gonna return. And so we're just gonna add something in the memory. What would you actually do is that memory or 0 dot zero rate of zero dot. I mean, what would you actually do? We need to check with the flag. So the first thing we need to do is going to make a big for loop, right? For column inside of 0 to bits, right? Next is one more for loop inside of this, which goes for a row in 0 to bits. All right, we're going to say let id is equal to format, right? Called row like that. We're gonna have an ID that formats this, which has a column and row, obviously. What else is gonna have? Column, a row. Yeah. So oh wait, what am I talking about? This ID. Yeah. Now we to check. We to check whether that is free. Wait a minute. No, 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 no. Yes. So we're gonna check flagger. So we're gonna check. We're gonna make one more function here. Um, is free. Um, self is gonna take in an ID and it's gonna return a boolean, right? And again, ID is gonna be a type of string. And it's gonna basically say if self dot flagger dot get, right? Get what? Get the ID. If that is equal, we're just gonna return this. We can uh, unwrap. Hmm? That. So yeah, if is free ID, yeah, we're gonna push it into that specific ID. We're gonna say memory. We are actually touching memory now. So again, memory of column of row dot, right? Column of row is gonna have what? A value. Dot value, right? Dot id is dot value, sorry, is gonna be value like that. Lifetime required, you're right. mm, yeah. So if it's free, we're gonna go there. So this is actually a very good method of doing it. So we'll check if you see all of this is false, right? Now mind, wait, no, where did you go? We never push anything, right? In the first place, we never push anything. Hashim dot push what? This gonna say we'll push in one, 1, 2, 3, 4, 5, 6, 7, right? Amazing. I hope it works. So first thing we need to check is that do we have any true here? Do we see any true? Oh yeah, we need to update the flag again. Silly, we need to do that. Hmm, hasn't changed. What led to that? First thing we need to do is that if it's free, we'll check self flagger, right? Dot update. How do you do it? How do you set no? How do you insert again? Insert ID. That's true. Until we pop it, of course. So okay, just gonna do. We can change that later. Maybe put it into an RC. First of all, let's do that. Right. This shows that it hasn't really. Right. You can see it hasn't really changed anything. What we need to do is that we need to uh so I'm gonna print ln id and it's free id sorry id and self are it's free id.com, right? And I don't want too many bits, so I'm just gonna make it to just one. It's a 1 bit virtual machine now. Huh. 1 bit virtual machine. No, see, how's it false? I think so the thing is that everything we did here is wrong. So flagger, if it's false, is if we're supposed to say this should be an entire thing should be and for this, so not for this, right? That's why it's not working. You see, everything is true. The thing is that you should only do this, and after you do that, you just break, right? You just get out of the loop. So no, break twice. Then my friend will say, we'll just return like that, right? So you can see that we can successfully push stuff. Now, one thing I'm going to do is convert this into 9 right? I don't want you to be here. I want you to be hash map colony dd p Anna dd uh, never mind. Remember always do this here. Sorry. Da. Yeah, here. So clear exit to be honest. Oh yeah, let's concurrent. We can see where's our true value. You can see there was a true here. 0 was true. That is amazing. So we can successfully push values in, right? We can actually push values in. So um amazing. That's amazing. Now should we call this push or should we call this um we can call this allocate. Allocate would be a more good word for this, right? I think allocate is a better word for this. It's not really push. It's not a stack, right? This is not a stack. This is memory. This you can call this the heap. So to make this 64, you want to make this 65 over here. So I'm just going to show you how that is a 64-bit virtual machine. We just created a 64-bit virtual machine, which looks so cool. You can see, I don't think development with this virtual machine is possible, right? So for development at least, we're gonna use a 8-bit virtual machine. So no unnecessary print statements there, right? So we can actually allocate. Now there's one more thing called free, right? You're supposed to free stuff. So let's do free now. Okay, so let's get started with free. I need to give the ID which you're supposed to free, right? So that means you're also supposed to give the ID here, right? You're supposed to return our ID, right? Like that. Now, if we really can't allocate here, we're gonna panic here. All right, we have to really, yeah, we're gonna panic. Rush VM, memory full. Oh no, how do you say this? Um, all memory allocated now. The memory of the machine is full. To allocate more memory, yes. How do I put the semicolon over there? That's what happens. So now we need a free. Right. So you need to give an ID. So what we say is actually simply so for the memory, right? Now we need to break this ID into the row and column. So the first two are the rows. Because we know. How do you say this? The first two are the rows. In a 64-bit virtual machine, oh, so that's the problem. The ID is a problem here. you need to make, so how do you convert um um a single digit to any digit? Let's just say single digit to double digit in Rust. We don't, okay. So you're telling me we can actually check over here. We can do a small little check. So if call is equal to 0, if call or wait no, if call is equal to 0, right? Let's so how do you do this? Call to 0 or row is equal to 0, right? Now sorry, if call is less than 10, right, and row is less than or row is less than 10, yank, paste, dd, like this. So you say 0 like that, 0 like this. We'll do that later, right? So I'm gonna cargo run. So you can see that record the two-digit number. Now the same thing. So 54. What is 54? Wait a minute. If it's less than 10, right? And 24 means it's 2, and this is 4. Wait, I don't understand. Let's go here. So every one of this. Wait a minute. ID 00. Okay, you are supposed to do the same thing here. Yank, right? And we need to do this like that, right? Same thing here. We need to yank this thing. We're gonna paste this thing, right? On a DD, I wanna equal this. I'm gonna go here to 0 and to 0 here. So what is this then? Okay, that's for the flag. I'm not really sure why a few of those flags are not proper. You can see 0805, then 85, 0806, and 86, which is not what we want. Right? It's not we want. That's because, you know what I mean? Now this should work. $53. So if I gotta get ID. Hey, what? So imagine if it's something like that, so that will become something like 00. If you have 65. Oh, look, yeah. Silly mistake. See, here also. Here also. Um, One more thing is that this is actually not right because one of them could be a double digit. One of them can be a double digit. You can't. You have no way of saying that one of them is not a double digit. So we need to fix that. That'll be a problem. Not right now, but it'll be a problem. Um, how do you say? It'll be a problem in 64-bit ones, right? It's a big problem in 64-bit ones. So this should work. You can see that this is in the way what you want, but there's a problem in 64-bit ones. So now we just check whether yeah that's allocated. So I'm gonna exit number one. But two is that we need to check one more thing. If call alright, else if the problem we can't really do that. We can't do that. So we check if call is less than 10 or this thing right. No, it is let id is equal to string colon new. Alright, what we say is that if it's like this, it's always going to be like this. Alright, you always insert it like this. If id is equal to what? Format of what? Like this. Right, mutable, obviously. I mean, we can do the check again. Okay, so there's a problem. So, and if it's something like this, then there's something like this. Else if it's one equal something here. Else if it's one equal something here. Obviously, there are better ways of doing this. We can do the optimizations later. Here and else. Obviously, you can't leave out else. It's just this. And here there is going to be id. The same format we're supposed to use every single where. Here we're gonna do something like this, right? Equal this out, right? Now we just do a single push. This is nothing, it's just this. I hope this works. Taking ID here now. While assigned to ID is never read. No, it is read. Set here. I'm not sure why. We need to do the same thing here too. See, I'm not really sure why it's not taking ID in. Maybe it's overwritten. No, I mean yeah, it is overwritten. Okay, we'll see. We'll see. We'll see. Yes, so this should work. You can see that it actually works properly. Let's just check whether our thing is inserted too. Yeah, it is inserted. Amazing. Wait, I have a doubt. Yes, amazing. Everything works properly. Now, even if you make this into 65, it should work. Now, this is going to be simple. So, we need to divide a string into two parts, right? Um, so let column is going to be our ID of 0 and an ID of 1, right? That's going to be of 2 and 3 and 3, right? Yeah. Cars of nth 0. Don't wrap, obviously. That was tough. Sorry. R2. Sorry, backpack. R2. F1. R3. So this, yeah, 4 characters. Yeah, that's nice. This is column and row, and let ID is equal to format, right? Column and row. Column and row. And what we're supposed to do is that I'm just gonna print out. Wait a minute, what did it, that's just useless. what did we just do right now? We're supposed to sell down memory not free, of column of row, right? This should be 0. 1, 2, 3, 4, 5, 6, 7, 8. As you size. Oh yeah, right. Wait a minute. Oh yeah, right. The column. That's tough then, because uh, as a U size, right? You can convert that as a U size. This thing dot obviously dot unwrap. How do you forget that? Do you need to call that? Yes, you need to call that. Okay, that's understandable. That's very understandable. This is what it is. So we're gonna go here. We're gonna go to main, and we're gonna actually allocate again like this, right? So I wanna see how it works. The first two should be allocated. First two is allocated. Now what I want to do is that I want to say let pointer 1 is this. Let pointer 2 is this. Right? I want a free, right? Rust VM dot free pointer 2. Amazing. You have to see that this is free. That is wonderful. Let's make this to 1 0, right? It has to be still the same, obviously. It is the same. It's amazing. So you can see that we have successfully created an 8-bit virtual machine. Obviously, we're just working with memory right now. The memory part of the virtual machine is actually over. We surely can have registers like a real machine has. So we can have registers, but as you have seen that we have right now, like have completed an amazing little small little 8-bit virtual machine, and it can actually allocate stuff now. For what I'm let me, so remember the example that I gave you in the starting, right? First thing, second thing, third thing, allocating. And when you free the let's just try the example that we gave before, right? Something like this, and then we free pointer 2, right? This is pointer 3. Then what we do is we allocate 4, right? So that will be, I don't know, 1 1 1, all of them must 1, right? Let's see what happens. This is exciting. So if you can see here, first is 0 0 1, second, okay, so third has been 1 1 1 1 1. I am quite not sure. Oh yeah, because when we pop, right, that was a good thing. That's a good thing. We forgot that when we're supposed to free it, we're also supposed to free our flagger, right? Dot insert id dot clone has to be false, right? Is it true or false? It's false. Now I think it should work, right? Let's run. Let's do cargo run, right? Oh my god, that's amazing. So this works. So if you don't understand by what I'm doing here, is that pointer 1. So we are allocating 1 first, right? Then we are allocating 1 0, right? Obviously, what I'm trying to say is that we are allocating, like, let's just say we're allocating this first, right? Then what happens is we are allocating this string. You know what? I'm gonna how do you create a new one here? How do you create a new one? How do you, or at least delete this? So yeah, delete it. So I think that's good. Okay. So what happens, right? Is that inside of our memory, imagine this is memory. Okay, not this big. Memory is this much. Memory, mm, yeah, memory is black. We have a first thing, right? We have our first memory block. Then you have a second memory block, right? Then we have a third memory block. We have a fourth memory block. We could technically make this a little bigger, right? This is how memory looks. Okay, not really, but so what actually happens first? This is how memory is. First, what happens is that it's blue. I need it to be very big. Not that big. This big is enough. Right, so we have the value. Okay, yank. How much? Okay, one sec. So yes, here if the value this thing, now that should be small. We have this value here, right? We have this value allocated here. So this is allocated, so that means I'm going to put that as red. Yes, this red, not that much. This is good, and this should be white. So you can see we have allocated something here. This is not free, this is allocated. Second thing, so I think I can copy the same thing. Second thing, and this thing and this thing. We have this, we have this, we have this. So we have this one, and a pointer 2 is this, right? A pointer 3 is the same thing, and a pointer 4 is this. No, pointer 4 is free. right? It's 0. Remember, if it's 0, it doesn't mean that it's free. It could show something. That's why we only free it when you call free. Sorry, when we set the flag at false when you only if you call free. So this is how our memory looked, right? This is how the memory looked. Amazing, right? Now what happens is that I'm gonna copy this. Let me just draw the diagram, right? What we do here, original memory, right? This is original memory, right? What we do is we free something, right? So we free pointer 2. What happens is this becomes freed. Okay, when we free pointer 2, this becomes this. But once what happens here, next thing is that when we wanna allocate something new, right? When we want to allocate, so sorry. So when we allocate something new, so we wanna allocate. So when we allocate this, what happens is that, so I'm gonna put this here. So when we allocate this, instead of allocating in pointer 4, it uses pointer 2 as it is free, right? That's what happens. What happens is that this, right? Background, what am I doing? 4, no, 3, right? Yes, and the stroke is white. No, stroke is red. Background is this thing. This is white. This gets allocated. So now let me explain everything once more. So this hand, this is our virtual memory, right? We have 1, we have 1 0, and we have 1 again. So what we're doing is we are freeing the pointer 2. That means if we are freeing this thing, right? So it becomes green, becomes 0. Next, what happens is that we want to allocate 1 1 1 1 1 instead of allocating in the next one. That, so actually what happens is that it's going to allocate over here, right? It has to allocate over here. um it should actually allocate over here in at this place, right here. But guess what, it doesn't. Reason being, this is free. So what happens is that our intelligent virtual machine allocates it over here instead of allocating it over here. I hope that's understood, right? So that means that's what happens, that's what's happening here, right? You can see that this is being allocated, and that is how our virtual machine is working, right? This is an amazing virtual machine. We are able to free variable. So as of now in our virtual machine, memory part is completely done, right? Memory part is completely done. Next thing we're supposed to do is registers. So okay guys, so for today I think that's a lot, right? That's a huge thing that we did. We have made our own 8-bit virtual machine. Our aim is 64-bit. If you want to make this 64, you can actually make this into 65 and it'll become 64-bit virtual machine. But till we finish developing, we're going to make it as an 8-bit. And for the last thing, we're going to make it 65, 64. So we did memory today. In the next part of this series, right, or the next part of this, right, part 2, we are actually going to make registers and other things that a real machine has, right? In Rust, of course. Rust is amazing. So thank you for watching the video. Like, really, thank you so much for watching this video. The link, all of this code will be open source. I will put it on GitHub. You can find it in the description. So yeah, thank you so much. Have a nice day.